Now let's look at the first example in this GVF subtopic. So in activity 4.4, we are requested to determine the type of profile for the following flow. So we are given figure A and figure B. So both figures were installed with Swiss gate. However, the flow condition from the upstream for figure A is at supercritical flow. Meanwhile, for figure B, the flow which is coming from the upstream is at subcritical flow. So both flow in this figure has created the formation of GVF before the Swiss gate and after the Swiss gate. So in this figure, we have altogether for each figure they have two formation of GVF. The first one is behind the Swiss gate. Here we can see the curvature. This is GVF curvature. So this is GVF, and the other one is after it passing the opening of the Swiss gate. So we can see this is the curvature. So this is the GVF profile. Meanwhile, for figure B, so before the Swiss gate, we can see the increment of the depth here, forming the curvature of the water profile. So this is one of the GVF, and as well as one is leaving the opening of Swiss gate. We can see the curvature here. So also this is the formation of GVF. Okay, please don't get confused. This is hydraulic jump. So hydraulic jump is one of the RVFs. So this is rapidly varied flow type. So we don't consider this in this example because this is another type of flow. So altogether we have 4 GVF to be determined. So in the question they ask us to give the name of the profile type of the GVF. So when talking about the type of the profile type, means that we have type of the profile for GVF, means that we need to give the name for the GVF. So the name of the GVF is consisted of the alphabet and also the number. So the alphabet is representing this type of slope for the channel, and the number is representing the region or the zone of the water profile. So the first step is to the classification of the slope. So in order to do so, we need to compare what? We need to compare Y0 and YC. So according to this figure, when we compare Y0 and YC here, we found that YC is more than Y0. So means that the type of slope is steep slope. So this steep slope, we represent them with symbol S. Okay, for figure B. Figure B here, we compare Y0 again, the same approach is made. We compare Y0 and YC, we found that it's the vice versa. Now, in this case, Y0 is more than YC, means that the slope is changing to my slope. So we write or represent the my slope as M. Now, to complete the name of the profile, we need to give the region or find the region for each of these GVF profile. For the first situation in figure A, because the curvature is existed at the top of the either of these two parameters, so means that our region is region 1. The second part here is the curvature is existed below one of these parameters, so means that our region is region 3. And same technique is applied to determine the region in figure B. So it is at the top of both of these parameters, so means that our region is region 1, and the second curvature here appears at the bottom at one of these parameters, so means that our region is region 3. So therefore we can combine alphabet and number together to form the type or the name for the type of GVF profile. So therefore we combine for the first case here is S1, S3, M1 and M3. Okay, the next example in activity 4.5, we are given a rectangular channel with bottom width 4 meters and bottom slope 0.0008, has discharge of 1.5 cubic meter per second, and along the gradually varied fluid in the channel, the depth at a section is found to be 0.3 meter. Assuming many n equal to 0.016, determine the type of GVF profile. So the first technique or step for us to solve this example is to extract out all the information given from the question. So we will present with their symbol here. So the first thing to give the name of the GVF profile is to provide what is the alphabet and what is the number. So the alphabet is represented by the type of the channel, whereas the alphabet is represented the region of the water zone. So let's go to the first step first by determining what type of the slope that we have in this question. So we need to compare y0 and yc. So does y0 or yc is given in the question? So look back in the question, no, they are not given. So therefore we need to determine both parameters separately. So in order to solve or to find what is the y0 value, we need to apply many equations using try and error method. So we have AR power of 2/3 equal to Q times N divided by square root S0. So at left side here we need to expand the formula for A and R according to the shape of the channel. So now we have the shape of the channel is rectangular. So A, use rectangular formula for A. R is rect, A over P. So we need to use P and A respectively for rectangular channel. So at the right side here, refresh again that these are the constant parameters that were given in the question. So we have 1.54 Q and many coefficient 0.016 and the channel slope 0.008 power of half. So solve using try and error method. Press your calculator and insert 100 when the calculator asks you to input the value, and finally we will obtain y0 value equal to 0.43 meter. And next we need to calculate what is the yc value, because again we are considering the rectangular shape, so we need to use the simple formula for rectangular. Yc equal to capital Q square divided by capital B square divided by G root 3. So substitute all the given parameters or the known parameters inside this formula to give the yc value equal to 0.24 meters. So when we compare these two, y0 and yc, we found that their values for y0 is bigger or greater than yc, means that our slope is bi-slope. So we only write the first alphabet M to give them the name for the GVF profile. We need to evaluate the region for this GVF. So the region for this GVF, because y, the GVF depth here is given as 0.3 here, so we need to compare 0.3 with 0.42 with 0.24. So we found that 0.3 is actually above one of these parameters. One of these parameters mean the region is located at the second region. So when we combine together, we will complete the profile type name as M2 profile. So if we want to graphically illustrate the formation of the M2 profile, is actually y0, we have y0 is higher than yc here, 0.4 is higher than 0.24, and 0.3 is actually located at one of these parameters. In this case is higher than yc, so it's actually the drawdown, is the drawdown shape, the drawdown curvature. Please correct this, drawdown curvature representing M2 profile. Okay, the next activity is when we change the shape of the channel into triangular. So it's actually the same approach that we applied before. However, the formula to calculate for y0 and yc is different from the previous activity. So a triangular channel has side slope 1 horizontal to 1 vertical, back slope 0.001, and mean roughness n equal to 0.015. If rate of flow is 0.2 cubic meter per second, first part is to determine the type of slope, and the second part is to give the limit of depths of region in region 1, 2, and 3. So again, the same technique, we extract out all the information given in the question. So we have triangular section, the side slope 1, S0 0.01 and 0.015, and Q equal to 0.2 cubic meter per second. Okay, we need to justify whether y0 or yc is given in the question. No, they both were not given in the question, so we need to calculate them separately. So begin with computing y0 first. So applying the same formula as before, many equation, try and error, many equation, try and error. So we need to expand A and R according to their respective formula. In this case, our shape is triangular. So use A and P here according to the correct formula for triangular. So the right hand side here for this equation is the constant value or the given value. Finally, when we calculate this, we will obtain y0 equal to 0.53 meter. If you notice here, because we don't have the denominator part here, the plus or the minus sign here, so it's actually we don't have to perform the try and error. Just bring it to the right and left and then equate them, and finally we'll obtain the value for rectangular. So yc, to calculate for yc, we need to use the general formula for the other shape. Don't use this formula, because this formula, this formula yc and small q squared divided by g root 3 is only used for rectangular. So this formula cannot be used in this example because our shape is triangular. So use the general formula to calculate the critical depth for triangular. So we have here again the same technique here. The left side here we need to expand according to the shape of the triangular. So we need to expand A and T according to the correct formula for triangular, and Q and G here is the constant value. So finally we obtain yc is equal to 0.38 meter. Okay, next we need to get what is the alphabet first for this GVF profile. So we need to compare Y0 and YC. So when we compare these two, we found that Y0 is more than YC. When more means our slope, type slope, is my slope, and we only write M. Okay, next. The question asks us to give the limit depth of flow in region 1, 2, and 3. Okay, in order for us to give the limit, we actually follow the previous note. In the previous note means that for M1 profile, the depth of flow for GVF, the curvature here, should be more than both of the parameters. So more of the both of the parameters, we look at the biggest one, because the biggest one will cover the lowest value. So the biggest one is 0.53. So therefore Y, the curvature depth of the GVF, must exceed both of the parameters. So both, the largest one is 0.53, which is Y0 value. For the limits depth in region 2, so the curvature of the GVF depth should be more than either of two parameters, either Y0 or YC. In this case, the curvature of GVF here is more than Y0, so it's enough to justify the M2 profile. For M3 profile, so the curvature GVF depth should be less than either one of these parameters. So in this case, Y is less than the lowest parameter here. So the lowest parameter here. Okay, I think I want to stop the class at here. So we will continue the class on Tuesday. So before I end the class, I want to recall what we have learned for today. For today, we have learned how to classify the type of GVF profile. So the type of GVF profile is consisting the alphabet and also the number. So the alphabet will determine the type of slope, whereas the number will determine the region of the GVF curvature location. So by combining these two, we will get what is the profile for GVF slope. So I think that's all. Okay, hope to see you by Tuesday. Okay, thank you and bye.